Chapter 15, Section 1, Energy and its Forms. So the first thing we're going to talk about is what is energy? It's the ability to do work. We talked about work in Chapter 14. Energy is also transferred by work. So energy can be changed by the amount of work that we're doing. And here's the interesting part. Energy is actually in the same units as work. So when you see joules, you need to really be reading the problem that's before you so that you know if I'm asking for energy or if I'm asking you for work. So again, capital J is the symbol you're going to see behind all of your pieces of information. Now, there are a couple of different types of energy. Kinetic energy is the first that we're talking about. It's the energy of motion, so any object that is in motion or moving has kinetic energy. So, kinetic energy depends on two things, the mass of the object and its speed. And we're going to abbreviate kinetic energy as KE for short. So, to calculate for KE, kinetic energy, the formula is 1/2 of the mass multiplied by the velocity squared. Now in this case we actually do have a square in the formula, so please do make sure that you're plugging in v squared for this. And also please make sure that it's only the velocity that you're squaring and nothing else. So let's look at an example. A 0.10 kilogram bird is flying at a constant speed of 8 meters per second. I want to know what is the bird's kinetic energy. So here's our formula, KE equals 1/2 mv squared. So we're going to plug in our 1/2, we just drop down. We plug in 0.10 for our mass, 8 for our velocity, and again, we're only squaring the velocity, so only the 8 gets squared here. So if you go ahead and you plug all of this into the calculator, I would plug in 0.5 for the half if you're going to plug all this in at once. So 0.5 times 0.10 times 8 squared. And you should get about 320 J or 320 joules. So quick practice problem. A 70 kilogram man is walking at a speed of 2 meters per second. What is his kinetic energy? So again, KE equals 1/2 mv squared. So you should have 1/2 multiplied by 70 multiplied by 2 squared. The other type of energy that we're going to be looking at is potential energy. So this is energy that is stored as a result of position or shape. So these are in objects that are not moving but have the potential to move. We're going to abbreviate this as PE. And there are two types of PE or potential energy. We have gravitational or we have elastic. The one that we're really going to look at is gravitational. So gravitational PE depends upon the object's height that it is located at. So it depends on mass, its height, and the acceleration due to gravity. So to calculate for PE, we have PE equals mgh. Now remember, m is mass, h is our height, and g is that 9.8 meters per second squared because that's a constant acceleration due to gravity on Earth. Elastic PE, we're really not going to get into a lot of this, but it's the potential energy of an object that can be stretched or compressed. So think about rubber bands. There are other forms of energy that we will go through as we continue with the physics portion of this class. We have mechanical energy, and we'll get to that in the next video. Thermal energy, chemical energy, electrical energy, electromagnetic energy, and then nuclear energy. And I'm just going to briefly touch base on what all of these are. So mechanical energy, it's associated with motion and position. So we're going to continue that in the next section when we continue kinetic and potential energy. Thermal energy is associated with heat. It goes with potential and kinetic energy, but it's part of microscopic particles and how they heat up, how they move, how friction interacts with those things. And we'll look at thermal energy in the next chapter after chapter 15. Chemical energy is another type. It's stored in chemical bonds, and once we get to the chemistry portion and we actually look into chemical bonds, we'll get to talk about chemical energy a little bit more. Electrical energy associated with electric charges, and we will get to that section too. Electromagnetic energy. So this is, think about light waves and how they travel through space. It's electric and magnetic at the same time. That's electromagnetic energy. And then nuclear energy we'll talk about when we get to the chemistry section. It's stored in atomic nuclei. And that's it for today.